Good morning. Today you guys are going to be learning about the polygon angle sum theorem, and your learning target is I can find the sums of the measures of the exterior angles and interior angles of polygons. Today we're going to only discuss exterior angles, and tomorrow we will discuss interior angles. I realize I did not give you your notes packet yesterday, so you can either follow along, take notes on a separate piece of paper, or if you happen to have a printer at home, you can go to Google Classroom. You can find the 6.1, the polygon angle sum theorem. Click on that and print the notes right here if you want to go ahead and write them down and then just replace this page in your packet. Either way, I don't mind. We will continue with notes tomorrow, so I do expect you to watch through this video. So, starting in, essential question: how does the number of sides in convex polygons relate to the number of the measures of the exterior and interior angles? They're actually very related, okay? So, we do have a new vocab term here, convex polygons, and that's pretty important. A convex polygon is a normal shape that you guys are probably used to. This would be considered a convex polygon. That wasn't a very good example. This one's basically the same, but a little better. This is convex. All of the angles are outside. All of the points are outside of your shape, okay? One of the definitions of a convex polygon is that if you draw a line through it, it can only enter and exit once in the shape, anywhere. As opposed to that, we have something that is called a concave polygon. I like to think about this as being a cave, right? So you can go into it. We have a vertex point that is inside of the shape. Another definition for this is you can draw a line through the shape that enters and exits more than once. So it enters the shape, exits, enters, and exits. That's considered concave. All right, so we are talking about convex specifically, this kind of shape here. So we're going to explore these. How does the number of sides of a convex polygon n relate to the sum of the measures of its interior angles? There's actually a formula. So we know the sum of the interior angle measures of a triangle in total is 180. We've been using that a ton. So we're going to decompose polygons into triangles and look for a pattern. So if we have a four-sided shape, that's what this n means, how many sides. You can draw a diagonal length n, and this creates two triangles, which means if you take 180 plus 180, a four-sided shape has 360 degrees. If you have a five-sided shape, that's how many sides there are, that's the n. You can draw two diagonals, which creates three triangles. So if you take 180, either add it 3 times or multiply it by 3, this gives you 540 degrees. If you take a six-sided shape, you can split it into 4 triangles. So you take 180 times 4. This is 720 degrees. Maybe you'll notice that it continues to increase by 180 every time. A 7-sided shape has 5 triangles. If you take 180 times 5, this is, let me see, I don't have that one written down. 180 times 5 is 900 degrees. Probably should have been able to do that in my head. Okay, so what happens if I give you, say, a 100-sided shape? You don't want to have to draw in all the diagonals and figure out how many triangles there are based on that. Maybe you can figure out a pattern. Notice for how many sides there are, there's always 2 less triangles. So with 4 sides, there's 2 triangles. 5 sides, there's 3 triangles. 6 sides, there's 4 triangles. It's always the number of sides minus 2 is the number of triangles that we then multiply by 180. So if you have an n amount of sides, any number, that's what that stands for, amount of sides, You just subtract that by 2 and then multiply it by 180, and you get how many degrees are total in your polygon. So we have a formula here. I would highlight this. If you have your manila folder from last semester, I would write that down. There are n minus 2 triangles in every n-sided polygon. Each triangle has a sum of 180 degrees. So the interior angle sum of an n-sided polygon is this formula. So we'll use that. So you try. How many triangles are formed by drawing diagonals from a vertex in a convex octagon? First of all, we have to know an octagon has 8 sides, and then we just use our formula. So we just take 180 times 8 minus 2. That's just 180 times 6, which ends, I think I answered this wrong. We'll do that next step. How many triangles are formed is what I'm looking for here. That's just our 8 minus 2. I got ahead of myself. Then we finish our formula. What is the interior angle sum of a convex octagon? That's where I take my 180 times 6. Or 1080 degrees. There we go. So we can see our theorem here. It's exactly what we just talked about, that we have our formula 180 times n minus 2 is our polygon interior angle sum theorem. It just states that the sum of the measures of the interior angles of a convex n-gon, that's any sided shape, is that formula. Now, you can actually use this to come up with another statement. If the measures of the interior angle of a regular n-gon, regular just means that it's all exactly the same, okay? You can actually figure out what each interior angle is. So regular means all angles are the same degree. If it states that it's regular, you can figure out what each angle is. Now, this formula, unlike the other one, solves for one angle. Okay? The other one solves for the sum of all the angles. You'll notice that the formula that we have here is just our sum formula, and then you divide that by the number of sides to find the singular angle. So it's very similar. I would also write this one on your yellow folder, and we will practice with it right now. Actually, we'll practice with it in a minute. We're going to do a different example real quick. So example 2 says, apply the polygon interior angle sum theorem. Jenna is building a corner cabinet to fit the rectangular room. If she builds it with the angle shown, how can she determine whether the cabinet will fit? So we have 90, 135, 135, and 90. We don't know what this last one is, but we do need it to be 90 degrees. So that way it fits in the rectangular room. So we're going to check this out. We're going to see if that's actually true. So first of all, I'm going to redraw my shape so that way I can visualize this a little better. So this one is the one that I don't know. I know this is 90, 90, 135, and 135. I just copied all of this down. Now, I do need to figure out how many degrees are total in a shape that is 5-sided pentagon. To do that, I take my formula. 180 times n minus 2 or 180 since it's 5-sided times 5 minus 2, or 180 times 3, which is 540 degrees. So if I now add up these 5 angles, the one that we don't know, plus the other 4, and then we solve for the one that we don't know, we can see if it is actually 90 degrees and if it will fit in the rectangular room. So we add those 4 up. This gives us 450. You can check on your calculator. And then we finish solving for the question mark angle. And we get that it does indeed equal 90 degrees. So the angle is 90 degrees. So the cabinet will fit in the corner. Okay, that was a lot of work just to figure out if it'll fit. But hey, I'm building a house right now and I know that you need things to work out. So it's not the worst thing to check. All right, we do have this U-try here. You can pause me. You can try it on your own. I'm going to go ahead and go through it. It says, what is the interior angle sum of a 17-gon? So we're going back to our formula. The interior angle sum is the formula 180 times n minus 2. Okay, that finds your total sum. So all I have to do is plug 17 in for n. So we have 180 times 17 minus 2, or 180 times 15. Just do that multiplication. Easy peasy on our calculator. You get 2,700. Now it wants us to do a different problem, unrelated, and figure out each angle of a regular n-gon measures 172.8. How many sides does this n-gon have? So we actually have to work backwards, okay? They tell us it's regular. That means we are using our formula from up here. So we have our answer, kind of, 172.8 equals our formula. Now, this is going to seem kind of weird to work backwards. Don't worry, we'll get there in a minute. So I just copied down this formula from up here, all the way up here, and now I'm going to use it. So I would say these are slightly tricky just because you have to work backwards, but stick with it. We need to get the n off the bottom here. So I'm going to multiply by n on both sides. That is totally illegal. And at the same time, I'm going to distribute this 180 through to each of these. So I now have 172.8 n equals 180 n minus 360. And now we have a fairly simple algebra problem to solve. I'm going to subtract 180 n on both sides because they are like terms. Using my calculator, this tells me this is negative 7.2 n. This will equal negative 360. I divide by negative 7.2. And this gives me that n is equal to 50. So this is actually a 50-sided shape. Pretty crazy. But our formula helped us get there without any guessing and checking, which is super nice. All right, we'll start up with example 3 tomorrow, and we'll probably do a little bit of review of this as well. Make sure that you've gone through these notes, and I will see you tomorrow.